Hello everyone. Today I'm going to discuss the last problem of Leetcode Weekly Contest 442, which is minimum operations to make array element 0. So what is the problem? We are given a 2D array queries where queries I is of the form L, R. Queries I defines an array of integers nums consisting of elements in the range L to R. Okay. So what we have to do in one operation, we can choose any two integers a and b from the array and replace them with a by 4 and b by 4 of floor. Okay. Now we have to find the minimum number of operations required to reduce all elements of the array to 0 independently for each query. We have to find the sum for each query. Okay, so let's take the first example where queries are 1 2 and 2 4. Okay, let me copy this and write it here. So queries are 1 2 and 2 4. Now for the first query, our array will be 1 and 2, right? Our array will be 1 and 2. Now what will you do? In one operation we can reduce this by 1 by 4. 1 by 4, if we take the floor, this will be 0, and if we take floor of 2 by 4, this will be 0. Now for the first query, the total number of operations is 1. Okay, because we have taken the two integers and reduced them by 1 by 4 and 2 by 4, so total number of operation here is 1. Now let's take for the second example. Second example will be 2 3 4. The array will be 2 3 4. So in the first operation, what we can do, in the first operation we can divide this and or we can say we can divide, I think divide this and this by 4. Okay, so now the array will become 2 0 and 1, and in the second operation we can divide this and this by 4, so the array will become 0 0 0. So total number of operation here is 2. Okay, so what is the total number of operations? Total number of operation here is will be 1 plus 2 3. Okay, I hope you get it. So we have to find the sum for each query, total number of operation, sum for each query. So let's discuss how we can solve this problem. So brute force way to solve this problem will be to iterate over every possible integers in the range, uh, let's say we have something like L and R for each query, so we'll iterate over all the integers between L and R. And what are the number of operations? For brute force solution, we have to find the number of operations, right? Let's say we are iterating for I equals to L and I less than R. Okay, I equals to L to R. Now what is the total number of operations to make a specific I 0? Okay, so total number of operation to make a specific I 0 will be like I by 4. Okay, I by 4, let's say I is 4, and total number of operations to make it 0 will be I by 4, the seal of this. Okay, so seal of, or we can say seal of I by 4, total number of operations to make this 0. So summation of I by 4 will be the total number of operations to make all the elements between L to R 0. But here there is a catch that we, in a operation we are choosing any two elements. Okay, in a operation we are choosing any two elements. So this sum is, let's say, C. Okay, then total number of operations, like in one operation we are doing two operations, right? We are reducing them by 2. Okay, two elements by 1, so total number of operation will be nothing but C by 2. But C could be odd also, so in that case we have to take ceiling of this. I hope you get it why we are doing this. So let's say for the brute force solution we have something like L and R, so we'll iterate over all the values from I equals to L to R, and we'll count the total number of operations for all the elements I. Okay, so for reducing one element I to 0, the total number of operations will be ceiling value of I by 4. Like for 4, this will be I think not ceiling value of I by 4, I think this will be like, one second. Okay, so this will be like 4, right? So we have to take, I think, ceiling value of I plus 1 by 4. Like we have to take 4 plus 1 by 4. Ceiling value of this will be equals to 2. Okay, so you can say that this will be I plus 1 by 4. So 4 plus 1 by 4 will be, ceiling value of this will be 2. I hope you get it. Now we have to the total number of operations here will be 0. This one C. Okay, now as we are choosing two elements and reducing their value by like dividing them by 4, so we have to take C by 2. Okay, but there are total number of operations, let's say, are 5, then we have to take ceiling of 5 by 2 will be 3. Okay, I hope you get it. Now this is the brute force solution. The time complexity of the brute force solution will be like order of total number of query into like R minus L. Okay, so but let's check the constants. What are the constants? This is not feasible because the constants on L and R are 10 to the power 9, so we have to think something better. Okay, now how we can make the solution better, I will explain to you, right? So my thought process is that I will solve this problem using bits. Okay, how I am solving this problem using bits? Let's say I don't think bits is also necessary, but let me discuss that with you bit part, because let's say some integer, let's say is, let's say 16. Okay, so 16 will be 16 8 4 2 1. Okay, so when I am dividing 16 by 4, what we are doing, we are just neglecting, we're just deleting the last two bits. Okay, when we are dividing by 2, we just delete the last bit, but when we are dividing it by 4, we just delete the last two bits. Okay, now after dividing it by 4, we have 100. Now after again dividing it by 4, we'll now have only 1. Now after again dividing by 4, we'll get the 0. Okay, so what you can see, that the total number of operations here is nothing but the highest set bit is 5, so it is nothing but 5, the ceiling value of 5 by 2. Okay, the ceiling value of 5 by 2, the total number of operation is nothing but the ceiling value of 5 by 2. That is the idea I have used here. Now that is the one part. Okay, for a specific I, we can find the total number of operations to make it 0, but how we are going to solve this for L to R? Okay, now another thing I have observed here is that for let's say we have some range from L to R. We can divide it in by in some ranges where with the specific value of this. Okay, total number of operations, to make it 0, let's call that O. Okay, O means the total number of operations to make it 0. So there will be some very few values. Let's say O1 will be from, let's say, L to let's say R1. Then O2 will be from like R1 plus 1 to R2, like that. The value of OK, let's say OK will be finally like RK plus 1 plus 1 to R. Okay, so this value of K will be very less. K will be like in the range 20 to 30, like the number of bits. Okay, that is the observation. So what we can do is that we can find the specific value of this this R1 R2 like that using binary search. Okay, so this value is like strictly increasing, or you can say increasing, right? This value R1 and R2 is increasing. What I am trying to say is that, let's say we have find the total number of operations for a specific value L. Okay, so let's call it OP of L. Okay, OP of L will be less than equals to OP of R. Let's say R1 less than equals to OP of R2, like that. Okay, so what we can do, we can do binary search to find the value of R1 R2, like that. Okay, so I'll go to the code now. I'll explain how I have solved this problem, and then I'll discuss the time complexity. Okay, so let's jump into the code. uh, this part is for finding the most significant bit for a number. I have copied this from Geeks for Geeks. Okay, uh, so built-in CLZ, this function, what it does is that it finds the total number of leading zeros in a number. Okay, so let's say a integer has 32 bits, right? So 32 bits, and let's say 16 has how many number of leading zeros? 16 8 4 2 1, right? So this has fifth bit as 1, so this will have 27 leading zeros. So built-in CLZ will give us value of 27. So most significant bit will be 32 minus 27 will be fifth bit. Okay, fifth bit. So that's how we are finding MSB in order of 1. Okay, now I am iterating over each queries. Now here this part is interesting. What I am doing, I am fixing the email one value ml as L. Okay, ml will point to L. Now ml will be the left value of the range. Okay, now for the first value of ml, we'll try to find the value of R1. Okay, how we are finding the value of R1? We are doing some kind of binary search. Okay, so I am fixing ms as msb of start. Now start is our start is ml. This is the value of binary search. Start is ml and end is R. Okay, now we are finding the value of mid. Now we are checking that if the most significant value of the start is same as most significant value of the mid. Okay, most significant bit of the mid. Okay, so let's say we have something like L and R, and let's say this is mid. Okay, so we are checking that the most significant bit of this L is same as the mid. Okay, if this is same, then we can increase the range. Okay, increase the range for this specific count, so we can increase the value of this L to M. Okay, we are just finding in the right half. Okay, that's what I am doing. If the count is same, then I am finding in the right half. Okay, so we are doing race equals to mid, and we are just going to the right half. Start equals to mid plus 1. Otherwise we are searching in the left half. Okay, after this operation is done, what I am taking is that total number of integers for this specific count, total number of integers for the specific count 1 will be r1 minus l plus 1. So r1 is our race and l is our ml, race minus ml plus 1, and total number of operation here is 1, the ceiling value of 1 by 2. Okay, ceiling value of 1 by 2, which is nothing but 1 plus ms plus 1 by 2. Okay, and after this operation is done, we are setting our ml to r1 plus 1. Okay, r1 plus 1, and we are trying to find the next range. Okay, I hope you get it. This is total value will be for the entire query we are finding the total value. Okay, now this total value could be odd also. That's why after the entire query is processed, we have to take and add our total plus 1 by 2, ceiling of total by 2, to the resulting answer. Okay, I hope you get it. The overall time complexity, let me discuss that. So here iterating over each query, so order of queue, and then we are finding that for each operation, each specific value of the number of operations, we are doing a binary search. Okay, so let's say number of operations is, I think, will be around 30 number of bits. So it will be like order of q into 30 into log of r, you can say q into 30 into log of r. So we can say that it will be around order of like 900 into q, because log of r will be also around range 30. Okay, so 900 into q will be our time complexity, and which is acceptable. I hope you got my solution. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. I will also share the link of the code in the description box. If you find the video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.